Balancing chemical equations. The law of conservation of mass is that matter does not go anywhere, essentially. In a chemical reaction, atoms and molecules are rearranged, but the same matter has to be in the products as it is on the reactants. So here we have a chemical equation. A chemical equation represents a chemical reaction. You always have reactants, which are on the left side of the arrow, and products. Now, you want to make sure that you have the same amount of each of the reactants as the products on both sides. So a trick here is to write out your elements on each side. So I have 2 irons, I have 3 sulfurs, 1 hydrogen, 1 chlorine to start on my reactant side. I have 1 iron, 1 sulfur, 3 chlorines, and 2 hydrogens. Now you can see that it's not a balanced reaction. So you add coefficients, a number in front of the compound, to balance out the reaction. So I see that I have 2 irons here, only 1 here. So I'm going to add, in a different color, a 2 in front of iron 3 chloride. Now this 2 distributes to the iron and it distributes to the chlorine. I have 2 irons now. Now I already had 3 chlorine, so 3 multiplied by 2 becomes 6. Well, on this side I have 1 chlorine, so I'm going to add a 6 now in front of the hydrochloric acid. Now this 6 goes to the hydrogen and the chlorine. 6 chlorines, 6 hydrogens. Now on this side now, okay, I have 2. To get 6, I'm going to have to add a 3, which goes to hydrogen and sulfur. So then I have 6 hydrogens and 3 sulfurs, and I already have 3 sulfurs on the other side. Now you're balanced. Sometimes all of the compounds may have coefficients, sometimes they may not. Just depends on how you can balance the reaction. Let's look at the one below here. This is a combustion reaction. A combustion reaction is a carbon-containing compound that always reacts with oxygen to form carbon dioxide and water. Going back to the top here, this, you can see, was a cation, metal, anion, with another cation and anion. The iron went to the chlorine, and the hydrogen went to the sulfur. This is called double replacement reaction. Now here, let's see how many we have of each. We have 2 carbons, 6 hydrogens, 2 oxygens. We have 1 carbon, I have 2 hydrogens, and I have these 2 oxygens plus this one. So I have 3 oxygens total. All right, so let's see how you can fix that. Well, what if I added a 2 here? Now I would have 2 carbons. 2 times 4 is 4 oxygen plus the 1 from water, that's 5. Then for my water, for my hydrogen, if I add a 3, I have 6 hydrogens. Then 3 times 1 plus 4, that's 7. Okay, well my oxygens are not happy, so I have to add something here. Well, to get 7, I can do 7 over 2. 7 times 2 is 14, divided by 2 is 7, so that would give me 7 oxygens. However, no coefficient is ever left as a fraction. So then what you can do is take the whole equation and multiply it by 2, which then will give you 2C2H6 plus 7O2 makes 4CO2 plus 6H2O. And then you double check if you are balanced. So now I have 2 times 2, 4 carbons. I have 2 times 6, which is 12 hydrogens. 7 times 2, 14 oxygens. Then by the carbon dioxide, 4 times the 1 carbon, that's 4 carbons. 4 times 2, 8 oxygens plus 6 times 2 hydrogens, that's 12. Then 6 times 1 is plus 6 oxygens, so I have 14 oxygens in total, and I am balanced.